Yeah, my name's Matt James. I make Damascus steel and knives from my workshop north of Taupo. In my earlier days I was a forestry worker, and I became interested in making Damascus and knives about the early, I was going to say 1900s, 1990s, and started doing that about mid to late 90s, and have done ever since. Today I'm going to try and describe to you how to build and operate this machine here, which is known as the Mcdonald rolling mill. The reason it's called that is because a guy by the name of Hugh Mcdonald is the person that invented it. When I say invented, most of you are probably aware that the rolling of hot steel has been happening for a long time. I think over 200 years now. But the concept of having a machine like this, which is something that you and I can use as artists, blacksmiths, knife makers. It has a small footprint, low noise level, and low power requirement. That's what Hugh gets the credit for. And the idea of it came about from him wanting to draw out the handles on tongs. He must have used a lot of tongs, I think, to put the time and effort in to think about this. The original mill had a groove in each roller, and the idea being that he forged and formed the jaws of the tongs and then put the steel through and rolled out the handle. And that was, he said it sort of worked and it sort of didn't, but that's the idea of the mill was born from that. He had a couple of friends, he was from Western Australia, he had a couple of friends who were knife makers there, and they asked him if he would make a mill for each of them. They could see the potential in it for knife making and for making Damascus steel and so forth. So he did that. And if any of you, you can buy the plans for this. If any of you do, you'll see a photo of the original mill there and something that looks like this. The original was quite similar, worked on the same principle. This is a little bit more tidier, if you like. So this is what he called the Mark II model. Before we go any further, what I'll do is just put something through through the mill. It's just a little bit, it's just a representative of what I would put through the mill, except it's wood, not steel. Just to show people here who haven't seen a rolling mill work, or in particular this one, the principle on which it works. It'll just give you an idea of how it does that. Thanks, Brett. So yeah, the top roller's the only one that moves. So I just put the work through, push down on the foot pedal, and it gets driven back towards me. I'm not dragging it through. Just once more. So it's as simple as that. It works on quite a safe principle in a way for rolling mills, in that it's, as you can see, it's pushing the work back towards you, so there's no likelihood of tongs, hands, fingers, anything like that going through it. And the other thing is, if you want to release the work, you simply let go of the foot pedal and the driving stops. Thinking back, the mill came kind of into the public eye in probably about 2001, maybe. I was subscribing at the time to a magazine called Blade magazine, which is from the United States. And I got my copy, and here's Hugh Mcdonald on the front cover, and they had about a 3 or 4 page article further on. So it made quite a splash in the knife making world at that time. It was quite a bit of news. Here's a different machine that we could use. I guess the good thing about it is you can build it yourself. The bad thing is you can't buy one. So just to digress a little bit, I can remember when I first got interested in knife making, it seemed that the only thing that you could really use for moving metal and forging that was thought about was a power hammer. And that's early 90s, and let's say into the late 90s, early 2000s, presses came into use. And I think there was a crowd in the States that brought out a press for people like us, a fast-acting, foot-operated press that I think was called an Imagination Express. Then we had two things, and because not everyone could get a power hammer back in those days. I mean, I'd never heard of Anyang in those days, and so you had to find a second-hand one. And then, of course, this came into being, so that made quite a difference. It gave choices where before they weren't there. The contact details for Hugh Mcdonald that made the mill were in the magazine article from Blade magazine, so I contacted him and talked to him about getting the plans. At the time he was selling the plans himself, and so the intention was that I would buy the send him the money for the plans, and he would send them to me. Well, I guess as the saying goes, the road to hell is paved with good intentions. I didn't send him the money and he didn't send me the plans. So over the years I'd thought a lot about building this and finally thought, well, get on with it. So if any of you are interested in building one, you can now get the plans from a website called anvilfire.com, and you can simply get on there, pay your money, download the plans and print them off. They come as a PDF file. There's about 46 pages, I think, of information and drawings and Hugh's ideas and thoughts on why he did what he did and why he didn't do what he didn't do. And they're almost worth buying just to get that. He's got quite a dry sense of humour. Once I got the plans, I looked through them quite a bit, and I talked to him, having already done so back in about 2003 or whatever it was. Talked to him again in about 2017, and one of the questions I said to him was, what's the start point? If you're building this, what's the start point for it? And he said, you can start anywhere you want. Really definitive answer, you know, it was really helpful. So I said to him, well, where did you start? And he said, well, I made the rollers first because I like doing lathe work. Right, okay. So I thought quite a bit about it, and in essence what he said is correct. You could take the plans, make any parts you wanted and put them all together, and they'd probably go together and make your rolling mill. But that's provided you stuck exactly with what he had in the plans. And he himself was a great believer in borrowing or stealing something before you bought it. And he said there's nothing you can't really change. So, you know, the freedom was there to introduce different materials or sizes, but you've got to be careful or keep in mind the effect it has downstream. And one of the bits that I changed was that channel. But as soon as, this is wider than what was in the plan, as soon as you do that, you're lengthening the camshaft carrier, the bottom roller carrier, the bottom roller, the top roller and the top cap. So straight away with one thing you've changed a whole lot. So after thinking a bit about it, I figured the best thing to do was to make the frame first and then fit everything to it. So the frame being this T section here, the two uprights and what I call there the top cap. There's no such thing in the plan as that top cap. I put it on myself. There is a piece of angle iron or square section welded across the top. I figured I had stuff I wanted to put on there, as you can see, so I made that. So once I'd got the frame together, I figured I could either start by making the bottom roller and carrier and mounting it in the frame, and then moving down through this area. That's the thrust strut, foot pedal, camshaft, and what's called the side lever. Or I could put the top roller on and work down through here, through the drivetrain and motor. I chose to do the former, the bottom part first. In hindsight, either one would have worked. And by just simply following through, it meant that you could figure out where things went instead of going hocus pocus at it. So that's just basically how I made it and put it together. The drivetrain parts, I'll just turn this slightly. You guys can see the drivetrain, I guess, just to give you here an idea. Some of those parts, like that main cog, the chain, some of the other, or two of the other cogs, I think, I got off Trade Me. I had a fair idea as to what the size should be. And then I went through a company that specialises in selling cogs and pulleys and so forth, and asked them if they could help me calculate what speed I needed. I knew what speed I needed that top roller to go at. I just couldn't figure out how to get it. So they did that and supplied the pulleys and so forth, the ones that I didn't have. So theoretically, when I'd finished, the top roller, which is the only driven roller, was doing 10 surface feet a minute. So when I cranked the mill up, it was doing 17 surface feet a minute, which I found was too fast. I've changed it a little bit now, and now that pulley does, that roller does 12 feet a minute, and that's fine, it's okay. 10 would be good, 17 was too fast. With regard to the operation of the mill, you saw me just putting something through it. The initial adjustment of the bottom roller, or the operation of the mill is made by simply the bottom roller coming up and pushing the work up to the top roller. And Hugh Mcdonald, I think, figured out that he needed to do it that way because, one, it's the only way you can stand on one side of the mill and have the work feed back to you. And the other reason is, if you look at the rollers, they're very small for a rolling mill. I happen to have 63 millimetre diameter stainless steel bar, so I used that for the rollers. And the rollers he built on the mill were anywhere between 50 and 75 mil in diameter. And that's very small for a rolling mill because the angle that the rollers take the work in is very steep, and they have no great ability to pinch work and pull it into the mill. So you really need to get the work into the mill and push down on the foot pedal and lift that roller into the work. I think because he made so many tongs, he obviously used them, I hope, and he figured on introducing the work with tongs and working half of it and then turning it around. With what I've put in the forge, you can see there's a handle on it, and for me it suits me to put a handle on things. I'm not very good with tongs and I don't have a lot of them, and so I weld a handle onto most of my work. The advantage for me is I can put all of it through into the mill and bring it through, and I can do that also with a power hammer or a press. So that's why I use handles. If you can see this guy here, when you put your foot down on the foot pedal, this is applying the foot upward or upward force to the roller, and it's coming almost up to straight. Okay. So the pressure you put on is coming off. Provided you don't over adjust this guy, your pressure you've got on there is very little. Yeah, it's very easy to keep the pressure on. I guess with something like this, it's a robust machine, but as a rolling mill, it's not as rigid as what you would expect to have a machine like this, or you'd want it. So it's got its limitations, and if you adjust the strut up to give you too much upward movement in the roller, it simply won't do it. You'll end up with your foot sort of up here, trying to push down on the work as it's coming through, and yeah, it doesn't work. So my average bite on work would be 1 millimetre. Probably 1.5. It does depend, of course, on the width, not so much the thickness, the width, and the temperature. It works, it's a lot easier to roll with work when it's at forge welding temperature than when it's at forging temperature. But having said that, it works at forging temperature, just has it's slightly more limited, if you like. Okay, I'll just get that going. I'll do a roll with the mill. This has been pretty hot. It's a little bit uneven. I think it's got some scale on it. Just not sure how it will go. Okay, that started off at 150 long, it's 10 mil thick, and it's quite hot because I've got about 4 rolls out of it. I'll adjust the mill up by a millimetre. And just roll it again. You can see it's curving a bit because I think the bottom roller moves slightly, so there's a slight anomaly in the distance between the top and the bottom roller at times. Better adjust it a bit. See, that's come back to fairly straight. Okay, it's probably enough rolling for now. So that's out to 300. One of the traits about rolling steel is that the steel doesn't get appreciably wider as you lengthen it. I find it to be quite a useful trait for me. I can set up something that I want to be relatively long, if you like, say 400 long, get it to the width I want, it's thicker than I want, and I just start rolling it. And apart from just keeping it straight, and I'll usually set up some dies in my one of my presses just to correct any movement, and it keeps the width the right width as I go. So you can just go into this rolling process. Let's say you take a millimetre off, you'll lengthen the bar by whatever percentage you you roll off it, so that the mill appears to work better on thinner material. And I'm not quite sure how to quantify this, but imagine if you had two bars that were 200 mil long, same width, one was 20 mil thick, one was 5 mil thick, and you take a millimetre off each one. So you take a millimetre off the 20 mil thick one, it's down to 19, and it lengthens by 10 mil. So you've taken 5% off it, you've lengthened it by 5%. You still only take a mil off the 5 mil thick bar, but you've taken 20% off, and it's lengthened by 20%. So it's gone from 200 to 240 long, visually quite a lot. But you've still just rolled a mil off. So I'm not sure how you quite quantify it, but it means that when you're working in thinner section, it appears to be, or is doing, it's moving the metal more, if you like. I've done a few things to this that weren't in the plans or whatever, and so they are putting the casters on it. That was a really good move. It's great to just tuck away in a corner if you're not using it. And I've also, for that reason, I've cranked the foot pedal so it's still at the same position it was before the casters went on it. I put a digital scale on it, which is this little guy here, and that's what I use to adjust it with. It's absolutely not necessary, but it's very helpful, and it's very helpful for me to keep an eye on what the mill is rolling particularly when I'm getting to where I really want it to be with regard to the finished product. The original had bushes on here. I've put self-centering bearings, and I've put the turbo on here. Now this is actually a fan, and that will, here it goes. I found that the rollers were getting very hot for me. So I've looked for this, sourced this guy, which is a fan that's made to move air from one room to another in houses, and it came with the variable speed on it, so I put that on. It's wired into here so that it can either run on its own, it can run with the mill, or the mill can run while that's not running, so you've got the choices. So I will quite commonly have that going while I'm forging. I found initially, once I got the mill up and running, that the rollers were getting too hot, so I put a freestanding fan behind it, and that did a job. This is much better, and you can just, it directs the air onto the rollers. I'm sorry, I didn't actually demonstrate this. This is what's termed the side lever, and the idea of it is to, I'll just get that back to its zero. The idea of it is to quickly lift the bottom roller. So obviously your foot pedal lifts it up. This star wheel adjusts it. The idea with this side lever is you're putting your work through, you bring it back out, and then you lift the side lever, you take it across to the next increment and back, and it lifts the bottom roller, just like the other adjustment does. I don't use it that much. I actually don't find it that good because it's moving a cam down the bottom there. The increments that you move the lever on are identical, but because you're moving a cam, that's changing wherever the position of it is. So it means that that first movement I made there will lift at about 0.9 of a mil. If you go to the second one, it does it about 1.6. The next one's about 2.7. So for me, that's too variable. I've come up with an idea to change that, which I think will work, but I just haven't got to do it. There's a couple of ways, if someone's looking at building one of these, that you could really make it a lot easier and a lot quicker. And one is to simply get rid of that completely and do away with it. That means that this camshaft down here, I call it a camshaft, but it's a piece of, I can't remember what thickness steel, 40 or 50 mil thick, that's off-center turned under the pedal here, so as it turns around it lifts the strut. It would save doing all of that, and you could simply have a pivot over which the foot pedal works. That would save a lot of work. The other thing that I've talked to a couple of people here today about is putting a motor on taking that whole drivetrain off. You can get a motor and a gearbox that would go on the side here and drive that top roller. And that would take a lot of work out of it. I'm not sure how the cost would stack up there, but so those are two ways that, if someone wanted to make one, it would save a lot of work. I also undertook to bolt the whole thing together. I think in the plans it's welded. I wanted to be able to disassemble it. I guess for somebody who can't weld, if you had to outsource your welding, the bolting would be a good way to do it. But for someone who can weld, that'd be a quicker way to do it. Depends how you look at it. And of course, like the fan digital scale, they're nice to have and they do a job, definitely, but you don't need them. You can get by without them. So I've found, for me, making this, it was a twofold thing. I was actually quite keen to do it as a project because I had the ways and means in my workshop. So that was fine, but when I got it finished, I was really pleasantly surprised as to how it worked into my whole forging system, because I have a really good power hammer, I have 2 hydraulic presses, and this thing is it's just got another aspect to it, and the ability to mix and match those is great.
Thank you, Matt. Thank you very much.
Thank you.